Hello everyone. Today is International Asteroid Day. The day is celebrated following this theme that the protecting our planet through awareness, science, and global unity. Today is also National Meteor Watch Day. The day, 30th January, is celebrated as National Meteor Watch Day to encourage us to look to the stars, to witness one of the night sky's most thrilling sights. So I thought that today, that 30th June, is the ideal day to talk about meteors, comets, and asteroids. So why they are important to us? Well, asteroids and meteors are, and even sometimes maybe comets, are important to us because uh, our planet earlier witnessed lots of vulnerability from these. We know that dinosaurs disappeared 65 million years ago due to the collision of one giant asteroid. And even today, we are still vulnerable. A asteroid or even a meteor can destroy a whole city or even the whole civilization. So we are not out of the ori from asteroid or meteors, and study them requires to protect the human civilization from future problems from this vulnerability. So today I will briefly discuss about comets, meteors, and asteroids. So I will start with asteroids. So what are they? It's asteroids are a small rocky metallic body that orbit sun, like our Earth orbits our sun. So asteroids are also orbiting sun. They are remnants from the early solar system that never formed into planets. So the age of asteroids is mostly same as that of our Earth or other planets. In the same process, the planet, the Earth formed. Same process, this asteroid tried to form like a planet, but they failed. So asteroids are failed planets. Asteroids are located between the region of Mars and Jupiter. So you can see here it's like a rocky belts. So the asteroids are located over here, and most of the asteroids are tiny in size. You can find different size of asteroids. Some of them are, say, centimeter size, uh, uh, meter size, but some of them are even kilometer size. The largest of them is Ceres. Its size is 940 kilometers. So it's little less than the distance between size of Calcutta to Delhi. So you can imagine that it's no way it's a small size. And recently, the Ceres earned the tag of a dwarf planet. So it's like Pluto. Ceres is also a dwarf planet. You can see that it has nice, almost sphere-like feature, like uh, most of the dwarf planets. So asteroids have three types. The C type is carbonaceous. So when the most of the materials in the asteroid is carbon, it's called C type. And the S type is silicaceous. So when it's mostly made of silicate, it's called S type. And M type is when it's mostly metallic. And now let's talk a little bit About comets. So comets are small celestial bodies composed mostly of ice, dust, and rocky materials. Comets also orbits the sun, but unlike the Earth or other planets, its eccentricity is high. So sometimes it comes close to the sun, but most of the time it's very, very far away from the sun. They are remnants from the formation of the solar system about 4.6 billion years ago. So the asteroids, comets, and our other planets, they form in more or less in the same time, and their age is mostly similar. Uh, when a comet approaches the sun, heat causes the icy nucleus to sublimate, releasing gas and dust that form a glowing coma and often two distinct tails. So, if you see carefully a comet, you will find not only one tail, but there will be two tails. One is the dust tail, and another will be iron tail. So, dust tail is mostly made of small particles reflecting sunlight and appearing curved due to the comet's motion. And ion tail, made of ionized gas, pushed directly away from the sun by the solar wind, appearing bluish and straight. So here uh, you can see the anatomy of a comet. The nucleus part is it's mostly rocky, and its density is very high. And when the comet goes close to sun, so it's a outer material sublimate, and it forms a spherical kind of gaseous things known as coma. And so coma is a bit high in size compared to the nucleus. Often it becomes 10 to 30 kilometer in size. And from the coma, you will find two tails. One is the dust tail, and other is the ion tail. The dust tail mostly follows the orbit of the planet, orbit of the comet, but it makes an angle due to its orbital motion. And the iron tail is usually in the opposite direction from the sun. So here is the location of the tails. You can see that the dust tail and the iron tail both are also the direction of the both tails are changing as it's moving the sun, going close to the sun and going away. And all the time, iron tail is located just in the opposite direction of the sun, and dust tail is mostly following the orbit of the comet, but making an angle due to its orbital motion. And now, where do comets come from? Well, comets are mostly found way out in the solar system. Some exist in a white disk beyond the orbit of Neptune called the Kuiper belt. We call these short period comets. They take less than 200 years to orbit the sun. So the Phellas Hallis comet is the example of short period comet. But there are other comets also which come from far away region. For example, from the Oort cloud region, which is the kind of the sphere-shaped outer edge of the solar system that is about 50 times farther away from the sun than the Kuiper belt. These are called long period comet because they take much longer to orbit the sun. So comets are referred in history uh, for thousands of years, and even in the prehistoric uh, age, the reference of comet can be found in the uh, different prehistoric things. For example, in the caveman also draw some of the comets. It found in many civilizations, in Indian civilization, Chinese civilization, and even Australian civilization. The record of the citation of comet found. And the name comet came from the Greek word comets, which means long-haired star. So the tail, basically, the earlier people used to think that the comets are a star with large hair. So that's why they gave the name the comets, which literally means in Greek the long-haired star. So there are plenty of molecules in cometary atmosphere, and I am specifically interested in molecules in cometary atmosphere because we study regularly study cometary atmosphere in radio wavelength, mostly in radio wavelength, but it can be studied in optical wavelength also. Most of the people study cometary atmosphere or comet in optical wavelength because that's easy to do. But myself and my students, we personally study cometary atmosphere in radio wavelength, in millimeter uh, and meter wavelengths using giant meter radio telescope, ALMA, and other telescopes. So here is the list of known molecules found in different comets. You can see that the different molecules, some of them are not that simple. For example, glycine. Glycine is very complex, uh, is found in cometary atmosphere. So you can be surprised to see that not only the simple molecule like CO or HCN is found in the cometary atmosphere, but a very complex molecule like glycine is also found in the cometary atmosphere. And here is the one of the example of our observation of our comet Neowise. We made the recent GMRT observation of the comet, and in the left side you can see that the continuum observation of the planet, of the comet. So you can see that the comet is very bright in L band in 1400 megahertz. And we also make the spectral observation and found strong hydrogen uh, H1 line in the from the comet. So the paper is already published in one of the international renowned journal. And we also found evidence of alcohol, methanol, in one of the observation of the comet. So here you can see that the emission lines and the models are exactly matched, and the abundance of the comet is abundance of the methanol is pretty high in this comet. So earlier I mentioned about glycine in cometary atmosphere. So in the right side, we discussed that how glycine can be formed in planetary atmosphere. Now, why I am mentioning glycine so many times? The reason is that the glycine is the simplest amino acid, and we know that the fundamental building block of protein, our flesh is made of proteins. The animals in our planet, the life in our planet is mostly made of protein. And the fundamental building block of protein is amino acid. And the simplest amino acid is glycine. So if glycine can be found in comet, then we can learn a lot about the origin of the life in our planet. We can think that whether the first life in Earth actually came through one of the comets, Be- uh, because we can see that the glycine is easily found in many of the comets. So, and glycine is since the amino acid is the building block of life, and the glycine is the simplest one of them. So if the glycine can come from far away region to Earth, so then it's made maybe directly linked with the life in our planet. And here is the detection of the glycine in one of the planetary atmosphere. So if you want to discover one comet or one asteroid, how you will do so? If you know that there's an asteroid or there is a comet and you want to just watch it, then you can just follow the sky chart or the NASA website, and it will provide you location. But if you want to discover a new comet or a new asteroid, then how you will do so? Well, it's not easy at all. So what you have to do, that you have to take a deep image of a part of the sky, preferably in the solar plane, uh, decades ago, and you have to take another image which is recent one, and then you will compare two images, and you will check whether some of the star is moving. So some of the source in the image is moving. So here you can see that you have two images. Two are actually identical image. In the two image, only one point is moving. The central bright point in the left image moved little bit in the right image. So and other points are stationary. So you have to take thousands of this kind of image, and you will find billions of sources points like that, and among them only a very few of them will be moving. Well, and now if a source is moving, it's not sure that it's a comet. It may be due to different reason. For example, it may be just a false detection. For example, just an airplane flying over that, or many other reason. A false source can be created. But if it's you can prove that it's a real source and its movement matches the orbital, the track of the sun, and then it can be classified as a candidate comet or a candidate asteroid. For to be asteroid, it has to be within the asteroid belt, and to be comet, it needs to revolve around sun with certain eccentricity. So to discover a comet, you need to study uh, thousands of images, uh, and preferably with 20 to 30 years uh, long images. For example, one image now and another image 20 to 30 years ago, and then you need to compare, and then you need to find one star which is moving, and that may be your comet or asteroid. So discovering one asteroid or comet, it's not easy, but luckily recently we are discovering many of them. So discovering comet or asteroid is not a very special thing. We keep discovering this kind of sources, and especially discovering comet is important because some of them may actually hit Earth, and it can make catastrophic events. Our civilization may gone just due to that event, or it will certainly cause more than thousands of atomic bomb. So so we need to be very cautious. But if we can detect them quite early, we can take plenty of precautionary measures. Now we are equipped with those measures, but so we need to be very careful for locating this kind of asteroids and comets because they are potential dangerous to our civilization. And human made many mission to study comet. Here I made example of three of them. The Rosetta mission, it's a mission of European Space Agency. They first orbit the comet Philae, and they also land on the comet. So it helped us to study the comet a lot. There was another mission of NASA known as Deep Impact. So that mission actually fired an impactor into one comet known as Temple One. So it actually intentionally collided with the comet Temple One and then studied what is the inside of the comet. And there's another mission known as Stardust of NASA, which went to one comet and collected the dust from that comet. So now human made plenty of missions only for the study of the comet, and we know a lot of comet. And last, I will discover about meteors. So we all love meteors, and the meteors is past part of our culture for a long time. So meteors is the streak of light produced when a small pieces of space debris enters the Earth atmosphere, and it's linked with cometary remnant. How? Because when a comet passes very close to Earth, so what it does is that it leaves some of the gases and some of the particles in somewhere in the space close to Earth, and when Earth orbits that region, and when Earth reached following the orbit, when Earth reach that the region where the comet left that particles, those particles came to Earth due to the gravitation of the Earth. So then we see more planet, and often the it goes like a star. So we all heard the three words: the meteorites, meteors, and meteorites. So these three words are it sounds similar. So sometimes we be confused then when something is meteorite and when it becomes meteor and when it's meteorite. So any small rocky metal debris in space is known as meteorite. Okay, and when a meteorite uh, goes goes close to the Earth atmosphere, and light phenomena occurs, and it burns, then it becomes meteor. And when a meteor reach Earth surface and it survives the Earth atmosphere, then it becomes meteorite. So any pebble size stone, it's in the space is meteorite when it enters the Earth atmosphere and create the light flash. It's meteor, and when it reach uh, the Earth surface, though very rarely, it's known as meteorite. Okay, so now you know the difference between meteorite, meteor, and meteorite. Okay, they are very close, but they are actually different objects. And I guess most of you have heard about the meteor showers. The meteor showers is the specific time of the year when the plenty of meteors enter the Earth atmosphere. So you will see meteors like a shower. So it's a really beautiful to observe. So there are many important meteor showers all over the year, but three of them are most strong. So first one is the Perseids, which one can see in the middle of August. The second one is the Leonid meteor showers. It's can be seen in the middle of November, and in the December you will have Geminid meteor shower. So if you want to see a shower of meteors, so you must try during this time. And to observe a comet, probably nowadays due to pollutions by the uh, MTI, probably you will not see the comets from most of the location in the Earth. You will need small telescopes. But to observe meteor, the by the naked eye, you can observe a meteor. Only you need to go to a dark place, and so observing the optically the meteor and comet is very common. But one can observe the meteor with radio wavelength also. So how to do so? So there's a three common methods by which one can study radio uh, observation of meteors. The first one is the radio meteor scatter, where radio waves are scattered from the meteors continuously, and it reflects back from the meteor tails and come back to Earth, and from that you can study the different properties of meteor, like its size, its velocity, etc. One can actually hear meteor using FM channel. So it's a amateur astronomers are doing it for a long time. So you can just tune your FM radio, and you can, especially at the time of the meteor shower, you can hear that there's a sound of meteor. So it will sound like a glitch, and if you record the sound, you can see the glitch also. And what I have done, I made the VLF study, very low frequency study of meteors. It's way back in 2002. We studied the Leonid meteor shower. So so meteor can be studied in very low frequency also. They can be studied in the FM, in the frequency close to the FM radio. That's the hundreds of megahertz frequency also, and they can be studied using the scatter methodology also. So with these, I just discuss different properties of uh, comets, asteroids, and meteors. I hope that it will help young minds. And if you have any questions, you can please ask. Then in future, I'll try to answer your questions. Thanks a lot.